Hi everyone. Uh, in this part, we will discuss about operational amplifier, uh, short for op-amp. Uh, the name has two parts: operational and amplifier. Operational. The first part is operational because this device you are seeing on the screen, this small black chip. Uh, Performs some mathematical operations such as addition, multiplication, integration, differentiation. Okay, so this type of mathematical operation is performed by this small black chip, what is called operational amplifier, op-amp. So that's why the first part is called operational, and the second part is amplifier. That means it amplifies signals. That's why it is called amplifier. So the whole name is the operational amplifier. We call it operational amplifier or op-amp. Okay, so in this part we will see some basic introduction about this op-amp. Okay, so we will try to understand by its block diagram. Okay, so the block diagram something looks like this. I will draw it. It looks like a triangle. The block diagram is looks like a triangle. So this is the block diagram of the operational amplifier, and it has two input. These are the inputs. This is the plus input, and this is the minus input, and one output. Okay, and it has two biasing terminal. One is plus VCC and another is minus VCC. Okay, so we call the positive input as a non-inverting terminal or non-inverting input, and the negative input as the inverting input or negative inverting terminal. Okay, and this is the output. This is the output, and the upper one is the plus VCC and the lower one is the minus VCC. So this is the block diagram of this operational amplifier, and we will try to understand its operation by this block diagram. Okay, so it has a gain. Okay, the operational amplifier has a gain. It is denoted as A. A denotes its gain. Okay, so gain basically the ratio of the output voltage and the input voltage. Let us consider that the output of this op-amp is V0 and the input of this op-amp is Vi. So the ratio of output voltage and input voltage is called the gain. Okay, so let us consider that we have given an signal. Suppose we have given a signal in this input, that is 2 volt peak to peak signal. 2 volt peak to peak signal. Okay, we have give this signal into the input. Okay, and also consider that the gain of this op-amp is 2. Okay, so A is equal to 2. Okay, so what is the output? So from this expression we can simply write V0 is equal to A Vi. Okay, so the gain is 2 and the input voltage is 2, so 2 into 2 is equal to 4. Okay, so the output voltage will be 4 volt peak to peak. Okay, so the output will look like this. So this is the amplified version of the input signal. Like the amplitude has increased. Okay, So here the amplitude is 2, but here the amplitude is 4. So the amplitude has increased. So this is the amplified version of the input signal. So this is how a operational amplifier amplifies a signal. Okay, so now we'll see why we call positive input as non-inverting and negative input as inverting. Okay, so we call the positive input as a non-inverting input because the whatever signal it takes, whatever signal the positive input, the non-inverting input takes, the output will not shift or the output will not invert. That's why we call it as a non-inverting input or non-inverting terminal. Suppose we will give this signal to the positive input and consider that the negative input is grounded. Okay, so we will give this signal to the positive input, and after amplification we will get this signal. So this is the amplified version of the input signal. This is the input and this is the output. So this is the amplified version of the input signal. So here you see that the input signal has started from 0 degree and the output signal has also started from 0 degree. That means the output signal is not inverted version of the input signal. That means that the output signal has not inverted. Okay, so this is the non-inverting function of the op amp. That means that whatever signal it takes, it will not invert the output signal. If you consider that the input signal has started from 180 degree, that means the output signal will also start from 180 degree, but it will be amplified. So it has amplified and it is started from 180 degree. It has started from 180 degree. So the output signal will not invert at the non-inverting input. Okay. Now we will see the inverting function. Suppose we have given a signal that has started from 0 degree into the inverting terminal. So now this is not ground, and now consider that the non-inverting terminal has grounded. Okay, so we have given a signal that into the inverting terminal of this op amp, and the output will simply looks like this. So the output has started from 180 degree. Okay, so the input has started from 0 degree, but the output has started from 180 degree. So the signal has inverted. Okay, that's why we call the negative input of this op amp as the inverting terminal or inverting input, because it inverts the input signal. Okay, so now we will discuss about the biasing terminal, or plus VCC or minus VCC. Let's say that we have used a 9-volt battery, plus 9 and minus 9. Okay, we have used a 9-volt source, DC source, to bias this op amp. We have to bias this op amp before doing some operation, because this is an active device. Every active device must be biased. Okay, uh, because without biasing, active device will not work. So as the op amp is an active device, we must have to bias this op amp before doing some operation. Okay, so consider that we have used a 9-volt source for the biasing voltage. So this is the plus 9 volt, and this is the minus 9 volt, and this is the 0. Okay, now consider that we have given a input to this op amp, have given a signal or input to this op amp, which is suppose it is plus 2 volt peak to peak signal. We have given a 2 volt peak to peak signal to this op amp. So the op amp will amplify the signal, amplify the signal, and the amplification will be limited between plus 9 volt and minus 9 volt. So it will look like, so the output signal will look like this. So the amplification is limited between plus 9 volt and minus 9 volt. If we use 15 volt instead of 9 volt, then suppose we have used 15 volt, plus 15 volt and minus 15 volt instead of plus 9 volt and minus 9 volt, then the amplification will be limited between plus 15 volt to minus 15 volt. So it depends, the amplification depends onto the gain, and also it depends on the biasing voltage. Okay, so if any reason the amplification, suppose that some there will be suppose that when we give the input plus 2 volt peak to peak signal as an input to this op amp, some error has occurred and the amplification has increased. Amplification has what can I say, that amplification has increased up to plus 9 volt and minus 9 volt. Okay, so the amplification has increased plus 9 volt and minus 9 volt. So now I will not get this portion. I will not get this upper portion of this signal. It will be saturated. It will be saturated to plus 9 volt and minus 9 volt. Okay, so that means into the output I will get only this kind of signal, because the output, the amplitude, the extra portion which is beyond the limit, okay, which is over plus 9 volt, has been saturated into plus 9 volt and minus 9 volt. So the output will not good because some portion of the output has been saturated. So you can, so from this you can say that the amplification depends on the gain of the op amp and also depends on the biasing voltage. Okay, so that's all. In the next part we will discuss some other features of op amp. So thank you, and don't forget to subscribe, and if it helps, then give thumbs up.